So here you have weak acid. So a weak acid dissociates partially. So we use this word dissociates, or you can use the word ionizes. Okay, I use the word partially. I think some books use the word reversibly. Okay, but partial dissociation, it's quite common. So I put them. Okay, maybe I shouldn't use bracket, but you shouldn't have multiple words. You should probably just choose whichever one you prefer. Yeah, okay. Into H plus ions in solution. So you donate H plus, but it's about partial dissociation into H plus in solution. Okay. So this next question is something on what we call how would equilibrium position change when you change the condition. You can watch my other short tutorial videos under the O-level concepts. Even though it's A-level concepts, it's something that's very important later on in A-level as well. But the idea is really there. So that's why I put it under O-level concept as well in that playlist. It's to do with Lee-Chatelain principle. It's to do with how the equilibrium, chemical equilibrium will shift when you change the condition. Yeah. So here's about concentration of ethanol. Describe and explain position. So they don't want the yield, they want the position. That means on the right hand side you have the product, on the left hand side you have the reactants, plural because you have more than one. This is the left hand side, this is the right hand side. Okay, forward reaction is from left to right, backward reaction is from right to left. Yeah, that's by default the standard definition all around the world. So as the concentration of ethanol increases, so what will your system do? What will your equilibrium do? The equilibrium will try to oppose the change. The equilibrium will try to oppose the change, and the change is increased concentration of ethanol. So opposing the change is the equilibrium will try to decrease the concentration of ethanol. How would the equilibrium do that? The equilibrium is the reaction, it is the system. Therefore, it will try to remove the ethanol. How can it remove the ethanol? It will react the ethanol, okay? By reacting more ethanol. And when more ethanol reacts, therefore, your equilibrium position will shift to the right. Because in shifting to the right, you will consume, you will use up, you will react more ethanol. That was your explanation, right? And now I'm just stating the equilibrium position. Now this is to do with temperature. So they usually give us the enthalpy change of the reaction, but they did give you the enthalpy change of the reaction here. So you use that to answer that. When they said the reaction, they refer to the forward reaction, okay? So we always have to specify, is it the forward or the backward, yeah? So the forward reaction is exothermic, meaning it releases heat, okay? It releases heat. It releases heat when you form the product, when it goes from left to right, okay? So what happens when temperature increases? When temperature increases, what will the equilibrium do? The equilibrium will try to oppose the change. It will try to reduce the temperature. How would it do that? Well, your equilibrium is exothermic. It means it releases heat in the forward reaction. In order to reduce temperature, it will release less heat because it's about releasing heat. So I can just release more or release less heat. I want lower temperature. I want to oppose the change. I want to go back to lower temperature. Therefore, I will release less heat. If I release less heat, I will favor backward reaction because my forward reaction is exo. It releases heat in the forward reaction. If I want to release less heat, I will favor backward reaction. But that is not the position of equilibrium. Therefore, equilibrium position shift to the left. So be very careful, yeah? So which direction it favors in, not necessarily specify the equilibrium position, so you gotta state that specifically, yeah? As required by the question. Next bit is a equilibrium equation. So they want you to describe and explain what you will observe when you add corn hydrochloric acid to this, alright? So when you look at this equation, there is hydrochloric acid in here, all right? But I would suggest you to actually have a look at the paper 2-1 of the November 18 as well. So that was a slightly trickier question where instead of something that appear in the equation, they talk about what will happen. You can also imagine it happening here. What will happen if I add sodium hydroxide? So it's not obvious, right? There is no sodium hydroxide here. But sodium hydroxide can react with this. Sodium hydroxide can change the concentration of this, and therefore it can affect the equilibrium. So that was quite a good question there. So I recommend you can check it out if you want to know about that kind of scenario. All right. So as concentrated HCl is added, okay, so your concentration, so what's going to change? So concentrated HCl would mean there's a higher concentration of HCl, right? Because that's what concentrated means, all right? Increases. So what would the equilibrium do? When the concentration of this increase, the equilibrium will try to decrease the concentration, all right? The equilibrium, meaning to say the system, if we use the system is also correct. The system is the equilibrium. The system is the reaction, is the equilibrium in this case, all right? The equilibrium will try to lower the concentration of HCl. How would the equilibrium do if the equilibrium wants to lower this concentration? It will have to use it up. It will have to shift to the left. When it shifts to the left, this concentration will go down. This concentration will go down. But this is important because of the change. All right. So it will shift to the. So it will shift to the left. But they say, what would you observe? You see, they don't want left or right. They don't want forward or backward. But based on the position of the equilibrium, we say that it will shift this way. What is important? This is aqueous. This is liquid. So aqueous means in water. So both are soluble. But on this side, you have solid. So what will happen when you shift to the left? So therefore, therefore you will get less, therefore there will be less Bi or Cl, solid, white precipitate, not PPT, you are in theory paper, okay? You'll be less white precipitate observed. Solution become more soluble. Solution becomes more soluble. Solution, because you are talking about something which is a solid there, it become more soluble, you get less of that precipitate because you favor to the left. Suggest why a change in pressure. Okay, so these are all aqueous, liquid, solid, aqueous. None of them are gases, so none of the reactants or products are gases, and pressure only affects reaction involving gases. None of the reactants and products are gases. Well, we can talk about are gases or are gaseous. Okay, it's up to you whether you want to use the noun or the adjective. Okay, so not affected by change in pressure. Well, I probably don't need the last step. Actually, that's probably just a waste of my time. Next bit is equilibrium. All right, so they want you to describe and explain what happened when you add sodium hydroxide to the orange solution. So orange solution is here. You add sodium hydroxide to this. You know what's the most common mistake people will say? No effect. And then you know why? They will say because no sodium hydroxide. But you're missing the point, okay? So when you have sodium hydroxide, you need to think about what is sodium hydroxide. It is a base. It is an alkali. Then you need to think about this side and also this side. What do they contain? Okay, OH minus, so NaOH will give you OH minus, so that's the hydroxide, that's the definition of a base. When you add it to the orange solution, okay, you increase the concentration of OH minus in the solutions. So with addition of aqueous NaOH, so the concentration of OH minus ions will increase. NaOH, or you can say OH minus ions, are alkaline. or you can say they are basic. So what will they do? Will react with H plus, which is acidic, right? Get neutralized. Okay, that's what the OH minus will do. It will react with acid, and then you will remove the acid. All right. So if you add it to the orange solution, let's think, it will react with this acid, and it will, therefore this equilibrium, the concentration of H plus will decrease. Therefore the concentration of H plus will decrease. So what will this equilibrium do then? This equilibrium will try to oppose this change. It will try to increase the concentration of H plus. The equilibrium will try to shift to the left to increase the concentration of H plus. Alright, what would you observe? That's the key thing. They are not looking for composition mixture. They are not looking for greater this or greater that. They're looking for what we observe because they have two different color. So you will see, more yellow coloration because you shift to the left, right? So you will see more yellow coloration as a result of the equilibrium shifting more to the left. Okay. And the explanation was basically the result of the acid-base reactions. OH minus will react with this, neutralize this. Therefore, the concentration of this, which is a reactant in this equation, it will decrease. And then how would the equilibrium react? It will oppose the change, right? In order to try to go back to equilibrium. Now, suggest why a change in pressure has no effect on the reactions. These are all aqueous, okay? We're not dealing, there's liquid there, but aqueous means in liquid water anyway. So none of the reactants or products are gases. And pressure affects gases the most, okay? As you would have known it if you know how to explain equilibrium position based on changes in pressure, yeah?